All right. Hello, everybody. We're going to get started. It's great to see you all here at Distributech International in Orlando. I'm Kevin Clark. I'm the content director for Clarion Energy, and I'll be introducing our panel today. Before we get into the panel, I wanted to note that in the event of an emergency and we must evacuate the facility, please walk to the nearest exits. You can see note the exits around the room, and in the back to my left, there is an emergency exit. That being said, this panel is called Holistic T&D Planning of the Future Grid Using Intelligent, Data-Driven Solutions from the Grid Edge all the way to Bulk Power Systems. And it's sponsored by Electric Power Engineers. This discussion is moderated by Hala Ballouz, who is President and CEO of Electric Power Engineers, and it discusses the intricacies of digital transformation with a particular emphasis on the pivotal role played by sophisticated data-centric modeling in influencing DER planning, operation and management, electrification, and the seamless integration of transmission and distribution planning. So without further ado, I will turn it over to our panelists here. Yeah.
Okay, good morning, everyone. I'm excited to be here. Welcome to the audience. Welcome to our great panelists here. As you see, they're sitting in the order that you see up there. This screen will come back a little later. I do have a couple of slides to go over first, introducing the significance of this panel and our goals here today. I want to thank Distributech for this great format. This is my first time to do this. I think it's a great way to organize this, and also it's a webinar that will be available tomorrow. Today, we hope to challenge ourselves and you about the urgency to prepare for integrated distribution and transmission, modeling, planning, analysis, and operations. I am, as mentioned, the CEO of Electric Power Engineers. Me and the company I have built, EPE, dedicated a lifetime to partake in the shaping the electricity of tomorrow through consulting and software services. Relentlessly and always thinking ahead, embracing new technology while predicting the challenges that come with it. I mean, this is a loaded sentence, but it's very important to think this way, and that's what I want to challenge all of us today. And always with a singular focus of maintaining reliability, affordability, and enhancing resilience. This is a nice slide up here. Make sure you see it. All right. A major paradigm shift is happening. The intense amount of activity on the distribution level will make it such that the aggregate of what's happening out there will make this side of the grid a major stakeholder impacting planning and operation of our grid, and flipping what we have done for the past 100 years on its edge, where the bulk system is no longer the only driver for reliability and resilience. Furthermore, the amount of activity on the grid edge with DERs of all kinds will dominate some of the transient stability, not a lot of technical jargon here, but some of the stability of the grid that's very essential. Furthermore, we want to understand from this slide, what it's depicting is what you all already know. From what we looked like 100 years ago, where it was passive load and then the bulk system and the transmission ISO driving what we do to maintain reliability and affordability, to where we are today, where this, although not being additive, but load and DER is growing on the grid edge, growing in size and growing in complexity. And what that looks like is really in numbers, I mean, close to 20 gigawatts, 15 to 20 gigawatts of rooftop solar in California is an example. Or electric vehicle sales last year, 2023, were close to 1.6 million, doubling from 2022. And also where we have the share of electric vehicles of our motor vehicles on the roads is now 7.6%. It's not insignificant. The data and what comes with it is ginormous, as now we have millions of points to integrate into our studies, into our operations, compared to a few thousand in the past. And more details, and those who do studies or operations understand what we mean by points. These are moving parts, not just predictable passive loads. I just want to take a moment, step back, and tell you something about what EPE has built. About 10 years ago, EPE, directed by me, we decided to embark on building a software platform modeling the grid edge in granularity, because we knew that if we didn't have something at our disposal of that kind and being able to aggregate all of what's happening out there and study it on the transmission as well, we will not be able to serve our clients like we do. The point being made here is at that time, I was questioned by internally in the company as well as by stakeholders, and why rock the boat with a business that's already doing fantastic, right? But we went ahead and did it. And I want to tell you, it's not only the tools that we built. It took 10 years to learn and have the processes and systems and understanding and the services around it in place. It takes time to build something. You cannot turn the switch on and off and say, tomorrow I'm going to start doing that. You need to do that within your organization. So it's never too early. And in some cases like this, it's actually a huge risk to wait. What does all this ginormous amount of data and granular grid models and technology of grid edge? I'm just going to list, and I'm running out of time, so I have 4 points to quickly make. We first and foremost need granular network models with visibility and connectivity across T&D. These are the components that are necessary to get where we need to be. Number two, we also need to be able to have those models integrate intelligence from the big data from millions of points and across very granular devices, models. We also need to start to have and adopt devices on the grid edge that can record, transmit, control, and analyze what's happening out there. And last but not least, we need stakeholders to collaborate, regulatory to be part of the equation, and internally and externally and across other infrastructure. I know as a power systems engineer myself that we can do this. But we can't do this with all these elements aligned. With that said, let's dive into the intensity of this problem with our panelists here. This is the most I will talk today, so thank you for listening to me. And the floor is theirs. I will be asking questions, and initially there'll be each one of the panelists will be answering one question. Then it's going to be a free discussion. And I challenge our panelists not only to tell us what they did, but also challenge us and be very open and honest about the conversation. So let's start with the first question, and I'm going to address that to Lavelle, Santosh, and Adam in that order. Can you please discuss a case study, pilot project, where digital or data-driven solutions have been successfully implemented or being implemented, and speak to how that does or you see it capable of improving T&D holistic planning? Thank you.
Sure, thank you for the question. Checking in the mic on?
Yes.
Okay, fantastic. So good morning. I am Lavelle Freeman, Director of Distribution System Planning at Eversource. Eversource is an electric, gas, and water company operating in New England across the 3 states, Massachusetts, Connecticut, and New Hampshire. My team is responsible for the planning of the electric system to serve both load and DER across the 3 states. A lot of the examples I'm going to give are from Massachusetts. And reason being, Massachusetts is particularly challenged with respect to DER integration and electrification and load growth. A lot of this is driven by state policy directives. In Massachusetts, we have about 1.3 gigawatts of DER currently interconnected in the state. For a state that doesn't have a lot of sun, you can see that that is a large amount of DER, driven again, as I said, by state policy directives. On top of that, we have some very aggressive and ambitious directives for decarbonization and clean energy procurement across the state. By 2050, we would need to integrate 16 gigawatts of DER. For Eversource, which is one of the IOUs in the States, National Grid is the other large IOU, and there's also Unitil. For Eversource, that means 8 to 9 gigawatts of DER in our footprint alone. The States also anticipates electrifying all load in the heating and the electric transportation sector. Again, what that means for our infrastructure is ginormous. I cannot underestimate that. But I'm going to give you an example from the DER integration perspective. With this 1.3 gigawatts of DER across the state, it is not surprising that there are pockets of our territory that are tremendously constrained. There are substations where the next megawatt of DER will trigger a massive upgrade of the substation on the order of millions of dollars, $10, $15 million for additional transformer, upgrade of existing transformers, maybe bringing in transmission sources for the new transformer. And this obviously brings DER interconnection activity to a screeching halt in those areas because of the cost causation principle. The next DER would not be able to foot the bill. And so the state of Massachusetts took an approach to develop a provisional planning construct that allows us, and it's the first in the state, first in the nation, it allows us to basically group DER at substations that are mutually dependent on each other. And with these group of DERs, study them as a group. So rather than studying each DER sequentially, we study them in the cluster as a group, and we develop a solution for the group. And that solution enables all the DER at those groups to be interconnected. But what is even more forward-thinking is that we understand that the solution that's developed, and that solution was developed based on granular analysis of every DER at every grid edge and looking at the system at a very detailed level. That solution also procures reliability for load customers, for ratepayers. And so we have transitioned from a cost causation principle to a beneficiary pays principle, where everyone who benefits from the solution now have a stake in paying for it. Right? So all of the developers collectively will pay for it, but we've also developed a construct where the ratepayers would also foot part of the bill. And the way we do that is by a cost allocation methodology that's really outlined and developed really well in the discovery for the docket, which is 20-75 if you're interested. And we also understand that once we've built this solution, future DER would benefit. Right? And so for the 335 megawatts of DER that we built the solution for, you could integrate another gigawatt of DER beyond that. And so we develop an interconnection fee called a SIP fee, capital investment fee, that every DER that's in the group and every DER that will show up in the future will pay that fixed SIP fee, which turns out to be less than $500 a kilowatt for all of the areas. And that provides some stability, some continuity for all customers. The other great thing is that we were able to take all this DER, aggregate it up to the transmission system, understand what it means for overloads on the transmission system, and from an integrated planning perspective, develop a holistic solution for DER, for load, for distribution, and for transmission that will enable the system to interconnect this amount of DER, transport it to load centers in the Boston, Cambridge area, and be able to reliably serve customers with this DER. So I will stop there, 5-minute mark, and pass it on to my colleague.
That's beautiful. Thank you.
Awesome. I'm Santosh Veda. I'm the manager for Distributed Energy Resource Management System at Dominion Energy. We operate across 16 states. We serve customers with gas and electricity. Specifically, the DERMS we're deploying is for Dominion Energy Virginia, where specifically some of the drivers for us is the Grid Transformation Plan as well as the Virginia Clean Economy Act. As part of these, we are required to modernize our grid, which includes upgrading our enterprise systems or deploying DERMS. As part of Clean Economy Act, we are mandated to go carbon neutral by 2040. Again, for a state like Virginia, with 3.2 million customers, it's a really big number. We are also required to have 2,700 megawatts of energy storage. We are also required to have 16,000 megawatts of PVs. Those are our mandates, right, over the next 10, 15 years. On top of it, we also have a lot of load growth. Right now, we are projected to have 46 gigawatts, which is a doubling over our 23 gigawatts peak that we hit last year. A lot of this growth is driven by data centers as well as electrification. Again, you may not know this, but 90% of world's internet traffic goes through one county within our service territory. And as you may be familiar, they are very energy intensive. And so we see that driving a lot of our load growth. So we have the business drivers, mandates, regulations, but also our own customer electrification that's driving the need for a lot of the DER integration within our grid. And that's where the DERMS is supposed to help us get there. So to highlight your question, what use case I would pick the question of DER management integration. And of course, we talked about how we're going to see millions of these points, and that's one dimension of the problem, right? The other dimension is the stochastic nature, the uncertain nature of these systems. When we did distribution planning, when all of this started, we would pick the peak time for the grid, and we say that is the most stressed time for the grid, and we do all of our analysis based on that. But now, when we talk about PV, the worst time for PV is not necessarily the peak time for the grid, because it's actually beneficial at that point of time. It really is when you have low load. At that point, PV backfeeds into the grid, and that causes additional problems, so you need to study more than just one point. But then if you have electric vehicles, then let's say they come home and charge at night, then you're going to see the peak shift to the night. So then the difficult part of the grid is not necessarily the peak time on a summer day. It could be evening on a peak day. But what if you have time of use pricing? Let's say the time of use pricing starts at 1 a.m. So you'll see the load shift further to 1 a.m., and that's not your worst time, right? And so this alone kind of shines a light on the complexity of the problem we're facing, where the tools that we have used so far is, I'm going to do one power flow, one-shot analysis at the peak for my previous year, except the growth of DERs is ushering in this complexity from the fact that the customer behavior is a huge factor that changes the impact on the grid. The PV output is a huge factor that creates additional impacts. If you didn't have your forecasting right, especially PV forecasting on a short-term basis, then you need to have additional resources to help make up for that loss. And so we're getting into this world of the place where we have all this uncertainty, but our tools, our models don't capture any of this, and we are to operate the grid, continue to operate in the grid with that future. And that's where we're looking at tools so we have the DERMS platform, which is a real-time tool that will help us monitor and manage all these assets in real time. It receives telemetry from the grid, and then it makes control decisions based on what it sees as optimal. And then we can set priority for reliability, or we can make sure that we're reducing voltage or making sure the customers are restored in a short amount of time. But it also means that we need to go into databases and operationalize these databases, right? Until we started deploying our DERMS system, the list of rooftop solars was more or less an Excel spreadsheet that was in someone's computer. List of electric vehicles. We don't know where they are because we have a program that has 1,000 electric vehicles, but we know there are 60,000 to 70,000 within our operating territory. We don't know where they are. So then we need to mine the AMI information for it and then populate our distribution network models with it, the behaviors of it. So that's the complexity of what we're facing really, is that we are increasingly headed towards a future where there's a lot of uncertainty, the behaviors are not captured in models, and yet some of a lot of our planning processes and the way we operate the grid hasn't changed. We haven't come up to that the future, I think. And on top of it, we also have FERC 2222. As you're familiar, we are one of the states. We are under the PJM, the market, and we are expecting to go live with FERC 2222 in 2026, which means we have all these distribution assets that are being aggregated. They go into the bulk market, they get dispatched, and then as a distribution utility, we still are responsible for maintaining the reliability of operations, given the unknowns with all these assets and where they are and how they operate and so on. So that's the challenge we're really facing, looking to tackle soon.
Good morning. My name is Adam Podpora. I'm the section engineer for electric distribution planning and interconnections at Central Hudson. We are a publicly owned utility in New York State between New York City and Albany. We serve about 300,000 electric customers, about 90,000 natural gas customers. And for those that aren't familiar, New York State is not vertically integrated. So all of the distributed generation interconnections we facilitate in our department onto the distribution system are third-party developers. Similar to Lavelle and Santosh, a lot of our goals are driven by New York State policy. So New York passed the Climate Leadership Community Protection Act in 2019, which sets very lofty goals for distributed generation interconnections, electric vehicle adoption, building electrification, and moving towards a decarbonized grid. So understanding that this was going to require distribution and transmission system upgrades to achieve those goals, in May of 2020, the New York Public Service Commission initiated a proceeding to implement what the state is calling the Accelerated Renewable Energy Growth and Community Benefit Act. So this act is geared towards those efficient and diligent investments in distribution and transmission planning together, as well as facilitating the upgrades and investments needed to bring the renewable energy that's upstate in New York down to the load center that is New York City. So the utilities within New York filed the coordinated grid planning process in December of 2021. So the utilities work very closely within New York to achieve these goals. We understand that everybody has their own intricate operating procedures. Not every utility is going to be the same, but we are trying to comply with the same legislation from New York. So we're going to try to work together to achieve those goals. And the coordinated grid planning process, CGPP, is an example of that. In January of 2022, there was a technical conference hosted by our Public Service Commission where we discussed the filing that the utilities provided and the next steps, which would include stakeholder engagement within our state, given that we aren't the ones applying and installing these renewable interconnections onto the system, yet we have to host and facilitate them. So as I mentioned, the goal was to decrease those congestion areas that are obvious within our state. And this coordinated grid planning process is going to be a multi-step 24-month process that's going to require that data collection from all the utilities, developing a model that covers the entire state, and then performing a study so that we can understand how to prioritize those investments and work at it together, realizing that each utility isn't going to be able to do this on their own if we're going to try to meet these lofty decarbonization goals. We have many areas within our own territory where the amount of distribution-connected renewable resources are backfeeding onto our transmission system, and now we have to juggle both distribution interconnections and transmission interconnections when reviewing the transmission system. So this is just one small piece of the pie, given that we have the building electrification, the EV loads coming. So we know that it's going to be a very dynamic system in the future. And as Santosh mentioned, we can transition to evening peaking or overnight peaking with charging, but then also, I'm sure Lavelle is seeing this in the Northeast, where we used to always be a summer peaking system, and now with building electrification, we could become winter peaking systems. So it's, understanding, is our infrastructure ready? Are our equipment ratings accurate and up to date in terms of summer rating versus winter rating, and what to expect? And this, the CGPP process is supposed to be on a 2-year cycle. So we are currently evaluating what that study process will look like, and looking forward to updating everybody in a year or two on how that proceeds.
Fantastic. Thank you. Can I have my mic on? Is it on? All right. Well, I just want to say what we all heard, but highlight some of the important parts. Some regulatory and policy and plans are really driving a lot of these initiatives and needs, but before we know it, it's going to be self-propelled. Cluster studies, cost allocation, these are things we're used to on the transmission system, impact on transmission from everybody, coordinated grid planning process, things we didn't see before, the need to upgrade systems on the transmission due to DER issues, load growth, load forecasting, granular data-centric time series modeling in the operations side, and we didn't even touch upon how do you inform the DERMS and the operations with the right planning tools and decision making, while making sure that we have the infrastructure in place. And last but not least is backfeeding into the transmission system and ratings of equipment, et cetera. So with that said, I'm going to go to Pete and James and pivot, same topic, but pivot more into the T&D planning in the context of what we just heard.
Good morning. I'm Pete Westlake. I'm the manager of new products and services. Probably the only non-engineer here so if you ask me a technical question about getting electrons from one place to the other, I won't be able to answer it. But I can tell you that one of the biggest business opportunities that exist is electric vehicles. Now, I work for the local municipality that generates, transmits, and distributes the power that you're enjoying right here. So we've got experience with the local distribution. Electrification of the vehicles is the biggest business opportunity that utilities have. It excites me. It scares the heck out of transmission and distribution. And if you're in that business, you should be scared, because when we look at the data, we've been mining data for DMV statistics, because it's the only area that we can actually get somewhat interesting information. We've been mining it since 2021. During that time frame, we have grown, the state of Florida has grown to 291,000 vehicles. Now let me just let that sink in. 291 electric vehicles are in operation in the state of Florida. Our service territory alone, we have about 270,000 customers. Our service territory grew by 150% this last year. We have now got the foundation to go and talk to our transmission and distribution who have before said, oh no, these are play toys, they're not coming. They're not coming to us. Now we have actual empirical data that we can go to them and say, look, this is a real thing. This is something that we need to plan. And one of the things you have to be concerned about is electric vehicles like to hang out in a gang. So when they come around, they come to your neighbor, they call all their friends and come out and have a party on the same transformer. So the problem is, how do we figure out where they are, and how do I warn transmission and distribution that it's happening? It's nice that I can take credit for having Orlando is now the #1 EV city per capita in the state of Florida, and the state of Florida is #2 in the U.S. I love this because I'm the business guy, right? I'm taking credit for the revenue that's coming in. But we need to figure out where they are, because if we're not a little bit scared about this, we are going to have some pretty significant issues. I mean, you heard, if they all plug in at 7 p.m., where's our new peak? Yeah. Right? So we've got to, time of use is interesting, but I think you need variable time of use. So I've got 270,000 customers. Does that mean I have 270 different time variations on my time of use? I don't know. That's pretty complicated. But that's where we are today.
Yeah, absolutely. Thank you. Great perspective.
Yeah, thank you. My name's James Campbell. I'm the Director of Innovation and Sustainability at Rocky Mountain Power. We're part of Pacificor, where we operate in 6 states in the West Coast. So give a little Western perspective here. We operate and do businesses, Pacific Power in Oregon, Washington, and California, and then we do businesses, Rocky Mountain Power in Utah, Idaho, and Wyoming, and we're part of the Berkshire Hathaway Energy family. And I'm based in Salt Lake City, which in Utah, where we're the only IOU in this state. And we're also a little bit different from the rest of the panels. We're vertically integrated, and we are the largest transmission operator west of the Mississippi. And some of the challenges, I mean, these are all national trends, and we have all the same challenges that we're all facing right now with really this kind of push-pull between electrification and then what I'm calling the digitization or the AI revolution that's really, really changed in the last couple of years in terms of loads, in the sense of it used to be, right, you were doing your chat GPT for your daughter's prom dress. Now businesses are all using this, and the load to run these tools are enormous. And the growth and the demand we're getting for data centers is incredible, and especially because we have some of the lowest prices in the country. So we're getting just about I'm sure every service territory is getting inundated with data center requests. So right now we're having this challenge, really, as a society. Are we going to put our resources, our capacity resources, to support this data centers and this digitization, or we also want to meet some of our other social goals that we want of electrification, of reducing greenhouse gas emissions through building electrification and transportation. And so, and one of the analogies is I was in a meeting with an OEM who operates fast charging stations all across the country, and they were complaining like they wanted their 5 megawatts at this one local distribution spot, and it's like you're competing with the 500 megawatt data center across the street. And so it's like this is the challenge. So really the ability to now meet these, especially on that distribution side versus the bulk side, because on the transmission it still takes 10 to 15 years to build new transmission lines. Plus we have the challenge of wildfires, that's a whole nother issue. Plus we have to, as we're decarbonizing our generation fleet, on the distribution side, it's becoming more and more important to be able to kind of solve it ourselves, so to speak. And so that's where really DERs can play a huge role, where we didn't have that challenge 5 years ago. And it was 5 years ago, it was how do we integrate rooftop solar at times when we don't need it. And what we've done is well, we work with, although we're vertically integrated, we do participate in CAISO in the California, and we have the duct curve there. So we've been the offload of taking California's solar generation, so that's been great. But now we're looking at like, okay, how do we now use these as a benefit versus this negative that we've kind of seen, rooftop solar. And so one of the things we've done is really pushed a energy storage program to couple it with the rooftop solar. And so we have a pretty aggressive battery storage where the utility, we provide an incentive, and then the customer goes out and buys all the assets and all the equipment, but because they took our incentive, we now get to dispatch the battery. And so we can use that battery then to meet various grid services, whether it's the primary one, I'd say on the value stack is the frequency regulation, but we can also use it for traditional peak shaving and demand response and hopefully contingency reserves and all the other different grid services. But this has been really, it's really changed. I'd say we did this program as a pilot with one of the largest VPPs. It was a 650 unit apartment complex with about 5 megawatts of on-site generation and 12.6 megawatt hours of battery capacity, or battery storage, excuse me. And that was really successful. And then what we were able to do was show that that program was a success. And now we've expanded this across our whole service territory. And so we went from just 5 megawatts of batteries to now we have 30 megawatts. And we're thinking in the next few years it'll grow to about 300 megawatts. So we're seeing this, and there's no, this is not being driven by public policy. This is being driven by customer demand, and which is a little bit different. We do have our public policy in our states, in our West Coast states, California and Oregon and Washington, and we have a complete different public policy in Wyoming, Utah, and Idaho, but our customers are the ones that are demanding this. So we're really trying to make sure we meet our customer needs. So.
Well, thank you. As I failed to mention initially, I wanted to say we have a really nice, diverse panel, different regulatory construct, different types, and different experiences, which adds to the challenge. It's not like we can take this and make a cookie cutter of the solutions, right? Everybody is, but shared experiences are super important. But I want to take from this last discussion here is the word scared, and it's very important. What you said, we should be scared at the pre-summer seminar when I spoke, and I think it resonated with a lot of people. I did say, adding to this problem we're talking about today, the DR grid edge, and we're looking at quadrupling the load in the next 10, 20 years, right? And we just spoke to that, and we have aging infrastructure. We do have weather and climate conditions that are happening. We already have resiliency issues that we have to challenge. So the problem is a lot bigger. But what I also heard, which is very important, while DER is a challenge, perhaps, it's actually a great opportunity, because if we're increasing the load, that's what I heard, and I agree with, if we're increasing the load significantly, then, and we can't build the transmission in time, this is also an opportunity done right to do it at the grid edge while we figure out the whole bulk system and DER system. This is very, very significant, more reason why we need to integrate the planning piece and understand what's upcoming, because infrastructure needs tens of years sometimes to be built. So with that said, I want to move to another question related to regulatory and policy, and ask the panel, and starting with Adam here, and definitely want Adam and Pete to speak to it from our previous conversation, but please everybody pitch in. What are the regulatory challenges or opportunities that you had to navigate with, and not just in the electric infrastructure, but also the other tangential ones, which we know electrification makes us really rely on understanding transportation and gas as well. I mean, this is a whole energy system.
Yeah, absolutely. So in New York State, I'll answer the first portion about some of the regulatory and policy impacts. And one of the struggles that we're having in New York, as I mentioned, we're seeing interconnections both at the distribution and transmission system, and they're both contributing to the same constraints on the transmission system. So it becomes a struggle to balance the queues between transmission and distribution, because they're both separate interconnection processes. So when those two collide, how do you appropriately determine which projects are ahead in queue, and how to allocate the costs for upgrades to both equitably? On the distribution side, New York State did come out with Cost Share 2.0. So now we have a mechanism for developers to share in upgrades that are required due to interconnection. So if a substation the transformer is overloaded, we need to go to a bigger size. Developer A and B can share in those costs, so it does not fall on the first mover solely. And as Hala mentioned, within Central Hudson, we have both gas and electric. And as New York moves towards a decarbonized future, we have plans to retire the gas system. But being that we live in a northeast climate, we rely on that natural gas for heating buildings, residential, commercial, industrial. So right now we are beginning to start a new integrated planning where we're looking at the gas and electric systems together and where they overlap. And do we have electric capacity where natural gas customers exist? And as those natural gas customers begin transitioning to electric heat, will we need to make investments on the distribution system to accept that load? We already have certain towns and municipalities that are not allowing for natural gas heating. They are strictly being, new construction must be electric heat. So we're already seeing this happening in our territory. And it goes to show that integrated planning isn't going to be just transmission and distribution, but perhaps your gas system as well. And understanding holistically, can you migrate from a siloed gas transmission and distribution delivery company to an energy delivery company. And so one of the projects we're working on now is developing a tool that can accurately convert customers' natural gas usage, CCF, into an equivalent kWh, electric usage. And we want to make sure that that tool we develop is accurate, because that's going to be what we use when we develop our planning studies and forecasting studies, and without getting too far into the weeds, but depending on if it's a ground source heat pump, air source heat pump, if it's going to be a geothermal network, all of these have different electric usages. So it's a complex problem, but one we need to start working on today, because if we start 2-3 years from now when the gas starts retiring, it's going to be too late.
Absolutely. And I just wanted to add to that, do you know that, and that was with the commissioners' hearings earlier last year, some of the big resiliency issues that are taking place across the country, a lot of it is because of gas supply shortages as well. So layer that on top, right, is not electricity needs to be aware of what's going on, gas as well, as we convert these things. So, Pete, you had something to say.
I'm gonna hit this from a completely different perspective. I can appreciate what policy is needed for distribution, transmission, generation, so forth in this field. However, what I need to know is where those things are, and DMV tells me down to the zip code. Well, I don't know how many transformers are in that zip code, so I don't know which ones these vehicles are hanging off. So I need for the policy to compel the DMV data to be released to the utility. I know that they're protecting personal information, and I get that, and that's not a problem for me. I can protect that, but I need to know with a lot more granularity where these vehicles are hiding, so that I can better plan my distribution and take a look at it. Right now, it really just doesn't give me enough information. For instance, in the state of Florida, there are 25,000 vehicles that their county of operation is out of state. And the reason that it's out of state is because the DMV data doesn't tell me where they're operating. It tells me that they're Hertz rental that is registered in the state of Oklahoma.
That's very significant to me.
I was just going to say, one of the other challenges from a planning standpoint. So, like, for example, we just met the other day with Salt Lake City, the largest city, in their fleet, and they want to transition their whole city operations. They want to electrify, and they want to come up with this plan. How do we electrify the garbage trucks? How do we it's like thousands and thousands and thousands of vehicles, 50 different locations, and their consultant was asking, well, can you get utility transformers and put them on hold and set them aside? And it's that same challenge of, well, we're not spending money until you spend money, until you sign a contract. And it's that challenge from a planning where could we get that flexibility with our regulators in that kind of traditional, used and useful, requirement where you can't get your recovery till it's actually used and useful. And so it's an interesting challenge, especially from transportation, where we know it. Right, you got to build it out, and then you got to build out the local network, and then you buy the vehicles. Well, that's not how vehicle procurement works, right? So
No,
it's,
they buy them and then come and talk to you
Yeah.
about, hey, how quickly can you get this hooked up?
and then trying to explain to them too, well, you only want it in a spike of load, which then is a burden over here on all of our other customers. So it's like, well, how can we start planning this? And then can we integrate you in with some other customers as well? So that's an interesting thing of this planning of how to start, and I think as he was mentioning, how do you start getting some of this information, working with other types of agencies and different governments so you can do more effective planning.
Yeah, this is, hope my mic is on. It's almost like a group therapy session. we all,
That's what we need.
yeah, we're all triggered by the same things. And I want to step back and I'll address the regulated question, but I just want to give a little bit of perspective of where I am. And it's kind of a stream of consciousness. So if I'm going too long, let me know. When I joined Eversource maybe three and a half years ago, after spending quite a long time in the consulting industry. And one of the things I wanted out of my role at Eversource was to make tangible contributions to what's happening in society. Right? And when we joined, the planning group was disparate. You know, there was DER planning that was happening somewhere in the engineering group, and there was reliability and resiliency was happening somewhere else. And one of the first things we did was to bring all the relevant pieces of planning together into one group. Right? So DER planning, distribution planning, reliability and resiliency planning, and then we added a key component, advanced forecasting and modeling. Because a lot of our forecasting was being done by the revenue forecasting team. That was not invested in looking at the granular impacts of a lot of the things that impact our infrastructure. EVs, where are they occurring? When are they occurring? Heat pump adoption. And so this team, stocked with data scientists, is able to go and look at demographic trends and understand where are the areas on our system that are more likely to develop EV. And that gives us some insight into the ground level adoption, and we can feed that back into how quickly do we change out the transformers and the secondaries. But then we build that up to the bulk system, right? And this team now is able to do two things that really help us with the bulk system planning. The 10-year forecast, to develop a more granular 10-year forecast from a bottoms-up perspective and a top-down perspective, looking at econometric trends, looking at EV, looking at heat pump adoption, looking at step loads, and tracking the step loads in a granular fashion, integrating with major cities, Boston, Cambridge, Somerville, understanding what's in their permit files and what they are looking at, and getting that data to our engineers so we can get an advance warning of the large step loads. That helps us to plan over the 10-year horizon. But also doing a long-term demand assessment. And notice I'm not calling it forecast, right? Because forecast is a very specific term. We can use our forecast to trigger projects. Our long-term demand assessment now says, based on the state policy directives, what is our outlook at our substations in 2040, in 2050? How quickly are we expecting heat pumps ESO's heat pump adoption, EV adoption? And that, to Adam's point, gives us the knowledge that our system will be switching from summer peaking to winter peaking somewhere around 2035. We know that. We know which substations are going to be winter peaking. So we can begin to address the ratings requirements. We can begin to address what it means for our substations in those areas. And what that does for us, it really helps us to build a holistic plan. And that plan was mandated, coincidentally, we started before it was mandated, but it was mandated by the Electric Sector Modernization Plan Act, or whatever it's called in Massachusetts, right? We filed that plan with the Department of Public Utilities on January 24th. And that plan is a comprehensive outlook. It's a 700-page document. It starts with the current state of the system. It goes through how we forecast. It looks at advanced technologies and how these impact the system. And it develops solutions for the 10-year horizon. And then it develops prospective solutions, but also policy recommendations and technology changes for the 2050 timeframe that allows us possibly to not build so many substations. Because in that plan, we are looking to build 17 new substations and upgrade 26 substations before 2035, in 10 years. Beyond that, we could build another 30 stations. But is that what you really want? Do we have the land for that? So the policy recommendations are helpful. And the regulatory angle here is that in Massachusetts, the regulators have given us support, have provided us with the ability to recover on costs that gives us ammunition to go out and proactively do things. To proactively, for example, build substations where we know DER is going to occur, where there's a lot of available land, and we know DER is likely to show up, and we can proactively build those substations because we have guaranteed cost recovery. In Connecticut, where we operate also, very different environment, right? They're saying, go build the substations for DER, but then come and talk to us about whether it's prudent or not. We're going to pull into a rate case, we're going to examine it, and maybe you get cost recovery. Who would do that? We are risk-averse entities as utilities. And so that is not in the best interest of customers to be able to create a regulatory construct where there is uncertainty. And I think the role of the regulator, and we're seeing best practices in Massachusetts, is to create that environment where we act in the best interests of all customers and utilities not putting its solvency at risk in the process. So,
Great.
right.
Thank you. I love that. So I heard also recap, supply chain issues. I heard EV adoption and also separately load growth, working with the utilities ourselves. We've seen some of our clients actually put a halt or consider putting a halt on accepting new load interconnections or being able to supply the EV charging infrastructure in a timely manner for the customer needs, which really needs to be addressed. I wanna pivot to something a little more technical and talk about the resiliency perspective, especially timely here. We're in Florida. There's a lot of situations where weather is a challenge, resiliency is a challenge. I'm going to ask a rhetoric question because I like to hear the answer the way I would like to hear it. Is do we really have what it takes to be ready to respond in case of a resiliency emergency situation with the granularity needed to leverage and control what's on the grid edge? And I would like to have volunteers who can speak to that. Santosh, perhaps. You're a volunteer.
Definitely. Well, are we ready? I think it's not like one step, right? It's not, we do X, Y, Z, and then we're ready for it. I think it's a series of steps. It's a transition. Like, we're working on things as we go. I would say, like, when it comes to resiliency, and again, to answer your previous question about a gap too, right? The assumption that we have is that the loads that are coming online, the electrification, they're all dumb. They just do whatever they want. There is no flexibility whatsoever, and that's not true at all. And I think the objective there is that, and we have seen this time and again, where when we had a polar vortex event in Texas or in Michigan, when people, the governors go on TV or radio and they say, hey, we would like, to lower your thermostat or turn off your non-essential load to help your fellow citizens. We would like, people have come up with it, right? They've helped lower their energy burden to kind of help the grid go through like the difficult event. So I think there is that flexibility in the load inherently, and I think the regulatory structures or the utility processes do not account for that flexibility. And how would we encourage that flexibility? And it doesn't need to be, there is a big event that's taken out half the grid. It's something that we can do from a day-to-day basis on, again, if there's a peak demand, is there a way to use more of the load flexibility?
Yeah.
And I think with that, we need to change the regulatory process, right? Like, for instance, right now, the only type of load flexibility that's prevalent is demand response. When we file a case for demand response, it usually has to go through 4 stringent tests. And so, now again, it's not that demand flexibility is not valuable, but it's the tests we have chosen are so narrow that it would come across as not being valuable. But being able to broaden that and say, okay, we're not just looking at system peak. Can we use them for maybe offsetting a substation? Can we use it for offsetting a feeder upgrade? So those are all good points, I think. And I think the new programs as well.
Right. And do we have the planning models with the granularity to allow us to prepare for these situations? That's really where I lose some sleep at night, because we are doing a lot of pilot operational projects and focusing on operations. What about do any of you feel their teams have the granularity in their planning to foresee these situations?
No.
No.
I mean, I think I think it depends on the application in a sense, but right, we're starting to experience 100-year events every year in a sense. So a lot of the historical data that what we experienced is not necessarily translatable to what we're going to be experiencing. So we need a little bit even more advanced than just modeling historical data.
Right,
I think it's a little more predictive, which is a little different in that sense.
Yeah, and I would say yes and no. We do have a base and a process and a methodology. In planning for resiliency, we did a lot of the work based on processes and mining data and looking at the impact of storms on specific zones, and developed the resiliency plan and then mapped that to the SAIDI and SAIDI improvement. We did not have a tool that could do that for us. And we understand the limitations, and so we're starting to build an ecosystem around the tool that we have, the distribution planning tool, and augment it with capabilities. We are looking for that tool that would allow us to do the granular DER planning, automating the interconnection process, maybe even to do transmission and distribution planning on the one environment. I think that would be useful for us.
I commend that.
Yeah.
That's what I'm calling for.
Yeah. We don't have that now, but we do have many situations where we need to plan transmission and distribution cohesively.
Yeah,
and we do it in separate tools, and
Holistically,
have them meet at the edge. But yeah, it's an ongoing search for us.
And with this kind of uncertainty, I think we need to lean more into mobility of how we respond. So for instance, if you can supersize a charging station in the evacuation route that's in the face of the storm versus supersizing everything, so no matter where it goes, it's not a problem. So I think we need to look at mobility of our services.
Absolutely. Thank you for the input. So we just have 8 minutes left. I'm going to ask the panel, starting with Adam and moving this way, to do 1.5 minutes now, calculating, of conclusion on recommendations you like to leave the audience with from your experience, and you might want to drop on stakeholder collaboration, internal, external, or any, where do we start?
Yeah. While the modeling complexity is one obstacle we need to tackle in integrating the transmission models, distribution models, the complexity of flexible charging, of smart inverter settings, of pairing PV with battery, and all these different technologies we're interconnecting. We need to do this in a matter where we are communicating with our stakeholders, because we've noticed in our service territory that there is such a benefit to being open and communicative with all of those developers that are interconnecting renewable sources on our system, as well as looking for the spot loads. Next week, Central Hudson's hosting our 14th Solar Summit. We do this every year, where it's a day that Central Hudson invites developers within our territory to come meet with us in person. We talk technical changes, policy changes, what's coming in the future, and it opens a dialogue where we can be just transparent with those stakeholders in our territory and make them understand the challenges we have, and that we're not trying to impede them or slow down the process of meeting these goals. It's just that we need to do so while maintaining safe and reliable and affordable power. And that's very difficult. And on the load side, we have so many customers that want to connect that 5 megawatt fast charging station at the thruway stop, but it's 10 miles from the substation on a piece of number 4 copper, and it won't happen overnight. So getting them aware that they need to notify the utility sooner than later seems like common sense, but isn't always the case. So it's important to be transparent and communicative early on.
Thank you. These are the future stakeholders that are like the generators. I mean, our
Yeah.
customers are going to become, in 10 years, I believe, just one part of the equation. I think that's super important. Thank you.
Yeah, I think my biggest takeaway is like being able to do more of the operational planning in the control centers, where we would need 8760 simulations, where we would need tools that would pull in data from Pi Historian or AMI data or set points for the PV inverters and the battery inverters and so on, weather forecast data, and bring them all in one place, do an analysis and show what is impact to the grid, how is the grid functioning. So really thinking of planning not necessarily as something we do for building the system, but for actually operating the system, especially when you have all this uncertainty. But the way you do it is being able to pull as much data as you can, building the capabilities for that real-time number crunching.
Absolutely. Feed your DERMS or other decision making.
Absolutely.
Thank you.
Yeah, I'd say the big takeaway is the importance of stakeholder engagement is particularly in setting what are those kind of operating parameters that we want our customers and developers to really go into. Because if we don't guide them, it'll be this crazy wild, wild west. And so we've seen it's been very effective by sitting down with trade allies and developers and say, okay, this is what you need to do. And the best way to do that is by providing an incentive, because that's what gets, and it's amazing that once you provide even a small amount, it will shift the market to a certain way. And so I'd say that's really been the biggest impact, is getting engaged, working with trade allies into the direction you want to go. The challenge is we have to know where we want to go.
I love that.
Yep, and along those same lines, absolutely, working with stakeholders, particularly the communities and the cities, very important. My first project that I had to push through a siting board was a nightmare because the community was opposed to it, and I was seen as an interloper who was trying to push something on them that they didn't need. We learned very quickly thereafter that we need to get involved with the city and help them to understand the need for the substation and take the input as to where the substation should be sited within technical parameters, and then help them to inform the community and bring the community along so that it's seen as an asset to the community and not a stumbling block. And then the second quick thing, non-wise alternatives. I think we need to be realistic about the role of non-wise alternatives and flexible interconnections. We cannot charge manage or non-wise alternative ourselves out of a lot of constraints that we have. We need to build infrastructure, but there is a place for non-wise alternatives as long as the utility has operational control of it. Otherwise, it cannot be classified as a distribution asset. And we are very clear about that. And I think that level of communication and a level of understanding needs to be had with developers, stakeholders, regulators alike, that we are sacrificing and risking reliability if the utility does not have operational control.
Okay.
So two quick things. The first thing is OUC is celebrating their 100-year anniversary. So it's taken us 100 years to build the generation, transmission, distribution for a 270 customer base that we have right now. And if you believe the scientists, and I do, the full electrification of our transportation market will double that grid. So we've got 10 years to double the grid. That's important for us to get ahead of that and to be able to deal with it. The second thing is, next week I'll be attending the Trucking Maintenance Council. The last time I attended, I was the only utility member that showed up at the show. If you are a part of a utility, you should be considering coming together with your fleet partners, because those are the folks that are going to scare you in the future, and you need to get to know them.
I love that. Well, thank you very much for a great panel. I want to conclude with a few notes that I am very pleased to see. Maybe 2-3 years ago, I wouldn't have seen that. Most of the panelists are actually on the distribution side, not all of them, but you see how everybody is thinking about the transmission already. A while back, like we said earlier, people would say, forget about it. We know how to do that. So this is very commendable, and I invite the audience, if they like, to ask some questions right at this point. This is a webinar that's recorded and will be played again tomorrow. There'll be opportunity for more questions, which this panel will take and answer as well separately. But we're staying here in this room, and we're available to engage in person or have any particular questions. Kevin,
Hala,
thank you so much.
First of all, a round of applause for our panelists. Thank you. And as Hala mentioned, the panelists have been gracious to stay a little longer than the bottom of the hour. So if you have any questions, I have the microphone. I'll come around. Just raise your hand, and we can answer any.
Thank you. I heard a key thing about incentives being the key enabler to get things to move in a direction so we can go in the direction we want to go. Lavelle, you mentioned Connecticut is a wait-and-see type situation. What do we do in those environments where we know we need to do some things, but we have barriers in front of us?
Yeah, that's a good question. And so one example in Connecticut was with AMI. We're trying to get the regulators to approve AMI, and they're saying, well, you can have AMI if you prove to us that you're going to have certain benefits that you purport to have after you install it, and so therefore you will be held to whatever you said before. Now, AMI is a technology that, when you're implementing it, you're proving out cases and you're trying to see how it helps you. And so the way we are approaching that is we're going to implement it in Massachusetts, where we have the regulatory support to do it. And then we're going to use those findings and to tell Connecticut, look, here's what we've done in Massachusetts. Here's how it has proven to be valuable in terms of storm response, in terms of being able to have visibility over assets and to be able to improve our modeling. And so these are the benefits that we purport. We are engaging very extensively with the regulators and trying to be responsive to everything they ask, but also trying to use our experience from other states to move the conversation forward, if that's helpful.
Great.
When we are talking about the planning prospects, when the question comes about a lot of unknowns in the planning, and as well as temperature adjusted line ratings, as well as grid resilience, as well as regulatory requirement of energy assessment. So in that process, how our planners are thinking about using AI technologies into the planning process, or using cloud resources to increase computing efficiency.
Good. Granular question. Anybody? I could take some of that. Go ahead.
So to your point, I think we have a lot of these tools. There have been traditional tools as well. And so one of the things we're looking at is EPE software. It's called NRI. And it is a cloud-based tool. And we understand, like, when we look at stochastic nature of DERs, or the fact that you have these parameters that influence the outcome, and you would like to optimize what is the right set point, or the outcomes. So that's where we're looking at one of those tools as the next generation capability to be able to run this offline and run multiple simulations parallelly. But more importantly, it's the data crunching that has to happen after, right? It's not just about being able to run a simulation. It's like, what are the key points that I need to be looking for? And I believe there are a lot of capabilities with the EPE's tool to kind of say, hey, we ran these simulations for all these situations, but then these are the 3 hours of the day that you need to be looking at. And then we can see what that means for, like, supporting that. But that's just a different paradigm altogether.
And just to add to that, it's cloud computing is important. It's just that example is a SaaS tool because of the need for cloud computing. It's necessary, and the big amount of data, but also, to your point, the granular modeling of line ratings or the ability to do the non-wires alternatives. A bigger answer to your question, yes, we need to do all of the above in order to, what we said earlier, leverage the flexibility on the distribution side to ride through a period of time where there will be a disconnect. Interesting to say, a paradox here, a disconnect in planning while the system of transmission and distribution has its seams dissolving. Does that make sense? So we're going to need to be very active on the distribution side.
Hi, I was curious of the distribution planning tools you're using today, or the vendors you've been talking to about all these needs, like which tools or features of those tools are seeming the most promising? And I know there are various tools out there, and of course a lot of them have booths here at DistribuTech, but I'm curious from your perspective what you're looking for and what seems the most promising.
So from distribution planning tools, we're really looking for 8760 analysis. We're studying a lot of our battery storage installations on a schedule, and to be able to understand where are the constraints happening seasonally and daily, and to be able to develop a schedule for those. We need to do 8760 analysis. Some tools are better than others. We also, and I think Adam mentioned this, what we call integrated energy planning, which is the gas electric coordinated planning, is very big for us right now. We haven't seen tools out there that are able to do this seamlessly, and so we're developing internal tools to be able to take the gas demand, translate it to the electric demand, superimpose this on our models, run the analysis, understand where the constraints are on the electric side, and then develop the upgrades. And then the third thing we're looking for, which would be huge for us, is automated interconnection analysis tools. Tools that on the continuum, from the review stage to the impact study, that are able to automate a lot of these processes. And to the extent that they can automate the full impact study, absolutely, great. And that will help us to get through some of the queues that we have that are very long, crunch some of these backlogs, and be able to give more accurate, faster results.
And I'll echo what Lavelle said, that in order to conduct these 8760 studies, you have data in different pockets of your company. So you need a tool or a software that can bring that data in. All this data is useless if you can't bring it in and use it effectively together. So if it's customer billing information, if it's substation load data, if it's your DER settings profile, all those different factors need to come into your one tool, your one software, so that you can actually analyze the data in a useful fashion. And sometimes that's one of the biggest obstacles, is even working within your company to tie all those resources together.
And even more complicated than that is that not all the data exists in your company.
Sure.
Yeah, because we look at property appraiser data, permitting data, things like that. You start aggregating all that, that gets messy.
And don't rely on marketing materials as the functionality of the...
And add equity to the equation of solving everything. But as a planner all my life, I can tell you scenario building, as I hear it here, becomes very important on an 8760 basis. You're taking solar profiles, different things from equipment capabilities, all these things, and putting them together to produce some tangible insight is very significant. Right? More?
Good morning, Sarah Chatterjee. I apologize, I'm losing my voice, but I will try to ask this question. How do you, or if you do, how do you see distribution planning processes changing and evolving with all of these new distributed energy resources? I think with a lens of affordability and being able to integrate these devices and DERs in, and evolving away from if you see this happening, evolving away from traditional distribution planning processes that might be looking at a one-time peak or a violation that's happening on an individual period from an annual analysis?
I know at Central Hudson we're using a probabilistic method to do that. I think one of the biggest challenges is finding a planning method that lands you between the very lofty state goals that when we look at today in 2024, how are we going to achieve that in 2035, 2040, compared to what might be more of a realistic or actual targeted. And understanding that gap is wide and we're going to land somewhere in the middle, but developing a planning method that gets you there accurately, reliably, and I think that's one of the biggest challenges.
I think one of the challenges is going to be with the non-wire solutions as part of that, because we don't have the standards in place. Because it's one thing when it's like, okay, you open up the book, here's the standard, this is how you follow it. But now we're trying to come up with novel solutions, and we don't have that yet. And so how do we kind of break through that to actually start getting them out in the field so we can develop the standards?
And I think the other part is, like, we think of planning as this open loop thing, right? You start with the model, you put your assumptions and you have your output. But in reality, like, especially when we have all these DERs, we need a system, like we are deploying a system like DERMS. One of the use cases is that we collect data, we look at all the engineering set points, then it creates a feedback loop into the model itself to say, hey, we had X amount of DERs, we called on the demand response programs, and this is the change in load that happened. And then being able to associate that with other data that you might have, like from a PI historian on substation data. So we haven't closed the loop on that yet, and trying to tighten that a little bit more.
I have to say,
go
ahead.
Sorry, one last note. We're finding that our distribution planning is really converging to the transmission planning domain. A lot of things that we've really reserved for transmission, we're doing them in distribution. We're doing PSCAD analysis for all our DER interconnections. We're the only utility in the country doing that. But it's because of the congestion that we're seeing that's leading to transient overvoltages. We have to do those studies. We're doing stability analyses in some of the areas where the load is getting us over the knee of that curve. And so we're starting to see a convergence of transmission analysis in our distribution space, which requires whole new skill sets and tools that we're not pivotal.
And one of the interesting things that's happening now is if you start making investments in some of this distribution planning that actually has a benefit at the transmission or the bulk level, how are those benefits transferred over, and who's paying for that, and
Back
who's
to
getting
cost allocation, I agree.
Well, yeah, and once you start getting into that, you start taking a look at, we do our cost recovery based on a long-term view of electrons going through that transformer into that house being paid on a regular basis. So what do you do when Lennar Homes decides to put 10 kW on every home, and we still have to build out the distribution that's the same without the 10 kW on the house? How do we recover our assets? We have to redesign our entire costing model.
May I say something that I believe this therapy session is necessary to become a workshop. I mean, it's so important to share all that information. In my mind, there is a sheet already with all what you said and putting there, but to what I heard also, it's processes to that question. It's processes and technology. We have the technical capabilities, or we can shape them already right now, but also the processes and understanding of what we want to do is very, very important, because we can't just do technical studies in a vacuum.
First up, thanks very much. This has been very therapeutic for me. Lavelle, so you talked a little bit about standing up a forecasting and a modelling team. Where I'm from in Australia, the utilities have kind of also dived headfirst into that over the past several years. And we're finding them wanting to do a lot more modelling, and now that you've talked about 8760 studies as well, they're really looking at that and starting to do it. And I was just wondering how far you guys are down that path. Have you started modelling those studies, or can you share a bit more detail about what you're doing there?
Absolutely. We are way down that path. We have filed in Massachusetts an operational tariff for battery storage that lays out how we will study battery storage on a scheduled basis. And we have developed the process. And the tools, I won't really get too much into the tool, not to blame each vendor for lack of capabilities in tools, but we are evolving in how we use the tools, and we've had to work around, develop Python scripts, for example, to do a lot of the things that we want to do that the tool may inherently not be capable of doing. But we have found that this is absolutely an imperative for us to do today for battery storage. And then what we have recently started to do is to start some flexible interconnections pilots, because we're hearing from developers of PV that, look, yeah, you're doing this for battery storage, but if you look at my PV plant and you're saying that if I interconnect, you would have to upgrade the distribution feeder and it costs me $5 million for your conductoring. If you give me a schedule that curtails me during those times when I'm causing constraints, I may be able to save, half of that cost. And are you capable of doing that? And so we have put out a standard that says that every interconnecting facility over 500 kilowatts must have an RTU. We have said RTAC, SEL RTAC, must have an RTAC, and that RTAC allows us to be able to have visibility over the operation, and in the future when we have DERMS, to be able to orchestrate them to change the set points and so forth. But this first step with the RTAC, it allows us to be able to now have flexible interconnections for PV, to give them a schedule of operation that is enforceable through the RTAC, visible to us, and saves them some interconnection costs. Again, for that, 8760 is absolutely required. And from a load side, we're also doing this for stations that we now have lots of DER and battery storage. And so be able to develop the solutions for those stations, 8760. It's the new paradigm. I don't think it's something that's exceptional now. We all have to get used to that mode of operation.
Good morning. My name is Steve O'Connor, Transnational Electric. We are a transformer manufacturing company. Prior to that, I was a project manager for power plants. Eversource might know the one in Charlton, Massachusetts, Blackstone Valley, Massachusetts, and Bellingham. You were talking about bringing gas in and turning it into electricity. That's what we did up there. We brought gas in to jet turbines, and they transformed that into electricity and distributed it out through the area. Is that what we're going to be seeing more of?
Well, so what I was referring to, so in Massachusetts, there's a docket called 2080 docket, the future of gas. And that docket postulates that we're going to be doing away completely with gas. So all gas fueled heating, and that's what I was referring to, will now be electrified, okay? And there are cities in the state that are even looking more aggressively at accelerating the transition away from fuels towards electricity. And so what that means is that we have to superimpose that gas demand, convert it to kilowatts, and examine what that does to our electric system. I wasn't referring to gas-fired generation, but certainly gas-fired generation is there, but that may be the next victim, right? And in my prior life at GE as a consultant, we did some of the earliest wind integration studies where we looked at, if you go to all wind, and we did the New York State study and some studies in California. What does that mean for the electric system? And what it means is that the system could be unstable because you need flexible generation to be able to balance the intermittency of renewable energy. And gas-fired generation and hydro are two of the more flexible generation assets. So from a bulk system perspective, we really need to think hard about if we want to go all renewables.
One thing that I know that there's those that see this vision of the future, but what the gentleman was just describing is kind of the shift from natural gas to hydrogen. And then that can become that kind of source that especially the general utility can manage that, whether it's for generation or localized industrial uses and stuff like that. But that's kind of that that would be that vision of that long-term shift as you move to where you still need some kind of form of liquid fuel for storage or balancing and individual uses. But that's a whole nother.
Thing. The importance of storage is significant.
We've enjoyed 100 years of pretty reliable power, coal, gas, whatever it is that we're dealing with. But now we've got wind that comes and goes. We're not the sunshine state. We're the cloudy state. So we actually have to study cloud cover to see what's going to happen to our transmissions lines as clouds cover over significant solar farms. We really need to reimagine how we're dealing with power, and you're right, storage is a key to the whole equation.
Yes, and new forms. That's why some people question whether hydrogen, where is it going to be? We need to put our faith in any new storage technology as much as we can to bring it here sooner. Yeah. Good.
Any last questions?
I think we had plenty.
All right. Thank you all. Thank you all for coming and participating. And thank you again to our panel, and enjoy the rest of the show.
Thank you.